Automated guided vehicles, or AGVs, are getting more and more popular in warehouses, in factories, or even in the streets. But naturally, AGVs need to communicate with their surroundings. You don't want AGVs running around uncommunicated. So that's why we have two communications experts with us today, Thomas Conz from our ISCA team and Martin Falkman from our Anybus team, to talk about communication for AGVs. Welcome to HMS TV.
Thank you.
Thank you, welcome.
Thomas, if we start by looking at this from a macro perspective, what are AGV users trying to implement? What are the drivers? What are they trying to achieve with AGVs?
Yeah, certainly one of the biggest drivers from a market point of view, it's the e-commerce. And we see AGV numbers doubling, double-digit every year, so really exponentially growing market. I would say what are they looking for? They are looking for mostly efficient production processes, but also stability in production, scalability. So what does it mean with the pandemics? We have learned that availability of labor is a topic. You don't always have it. It's about getting skilled labor, another issue here. And if you're using AGVs, you can provide efficient operations and you can really scale your business and you have stable production processes which help to deliver what you want to give to your customers.
Right. If we look at the communication part from a more technical point of view, what are the challenges that AGV manufacturers face when they're implementing communication for AGVs?
Yeah, I would say AGV is a quite complex system. So you have different kind of communication technologies for the drive, the batteries, also the outside communication on the wireless topics. And not only that, and just making it happen, but also making it happen in a safe way and in a secure way. That's really a challenge to customers that are frightened day by day and that they need to work on with us.
Right. Because we're not talking about regular communication here like you have on your Wi-Fi or Bluetooth at home. This is really ruggedized and industrialized. What would you say are the differences between an AGV need to communicate and your home network, so to speak?
Yeah, I think it's about latency, throughput, and also coverage of multiple access points. So if you're at home and you're walking around with your iPad, going to the terrace, and your kids are on the network at the same time, you don't really see that much of the latency. But if you imagine you have an AGV running in a production environment and you're just standing within it and you're not in a confined, secure zone, then you need to ensure that once the wireless breaks up, the AGV stops, and that's really giving you downtime. So you want to have a stable network, low latency, that you have a good communication on site.
Yeah, right. And HMS has been working with communication for AGVs for quite some time, and one of the products that have been very successful is the Anybus wireless offering. And Martin, you have a couple of examples here, the Anybus wireless Bolt and Bridge. What are they and why have they been so successful for AGVs?
Yeah, right. I brought with me two products here, the Anybus wireless Bolt and the Anybus wireless Bridge. And why they are so successful is essentially because they fit very good into industrial applications in different form. Bolt and Bridge, they are essentially the same thing from an electronics and radio perspective, but the mechanics make them fit in different physical locations. So if we look at the Anybus wireless Bolt, for example, this has on one side a built-in antenna. On outside, it's IP66 and 67. Then half of the product goes inside the product through an M50 hole, a 50 millimeter hole. And on the inside we have a RJ45 connector with Ethernet 100 megabit. And what we do is that we transfer transparent TCP/IP and UDP communication basically. So it's very versatile.
Right. And on the outside it communicates via Bluetooth and Wi-Fi. From your experience, what are AGV users choosing as their preference?
Yeah, actually both. We see in different applications they select different technologies. One thing is that Bluetooth is very robust and stable. It's not the fastest technology, but it's very reliable. And another thing, a reason for selecting Bluetooth can be that the Wi-Fi network is already congested. For example, we have a very good customer example in Germany at a big car manufacturer near Berlin, where they choose to use wireless Bolt and Bridge with Bluetooth because they did not want to congest their existing Wi-Fi networks.
Right. Tell us a bit more about this example in the German car manufacturer. What is their setup like? How have they set it up?
So they have about 50 plus AGVs now, and in the AGVs they use the wireless Bolt. So they put this in the control cabinet on the AGV, and in the roof they use the wireless Bridge to put it like this. So the wireless bridge and the wireless bolt communicate over Bluetooth, and these 50 AGVs roam between different access points. The bridge is an access point in this case, and they have about 35 different access points for these lines. I think they run about 6 or 7 lines with trains going around. And what they use is traffic control for with Bluetooth and bolt and bridge. Right. So to avoid congestion in crossings.
Right, excellent. So that's a perfect example of how the HMS technology is used in AGVs. But there are a lot of other challenges that AGV manufacturers need to cater for, Thomas. I know that batteries is a specific challenge for AGVs.
Yes, batteries are becoming more and more important also on the technology progress that we see with them. So in the old days we had the lead acid batteries, having no communication, just the power on them, quite heavy and also not that good in density and performance. And nowadays we see a lot more of the lithium-ion batteries integrated into HEVs in new ones as well as in retrofitted systems. And the two main challenges for the customers is how do you ensure reliable connectivity to the CAN open communication standards in that demand? And the second to it is how can you protect your systems from EMI, electromagnetic interferences that can destroy your electronics? And there the topic of galvanic isolation on the repeater as well as the CAN communication, it's something we can easily solve for our customers.
Right. Safety is another very important topic, and safety is something that HMS has been working with for quite some time. Can you elaborate a little bit on the safety aspects of an AGV? Of course, you don't want it to run away and go havoc in a warehouse or whatever it may be.
Yeah, safety is a really, really nice example because the demand is getting bigger and bigger and the standards on the market, like the different norms are developing by region. So we have a lot more customers coming to us and asking, okay, how can we set this up in a proper way? And we are quite proud to have some major OEMs in the HEV business working with us, having their standardized HEVs working with HMS technology. And certainly we have here the local parts and the wireless parts, which maybe Martin you can add in later on. On the local part, one of the demands, for example, is how do we make a safe stop? So if you lose connectivity, for example, how do you ensure that you have a safe stop? And you, for example, Thomas, if you're in the factory, you're not going to hit by an HEV if it gets safely down. And that's what we can, for example, do.
All right, okay. And safety can actually be implemented on the Anybus wireless bolt and bridge, right?
Yeah, that's right. So many safety standards, like protocols like ProfiSafe and Ethernet IP using SIP safety, they are using a principle called the black channel principle. And that means that the endpoints are safety certified, but the parts that form the link between the endpoints does not need to be certified. And this can be used for wireless products like bolt and bridge. And we actually have statements on our webpage that can be downloaded stating just that according to the standard this and this, it's possible to use these wireless components as a part of the black channel link. Right. The important thing is that it's not all applications that are suited for use with safety communication. For example, it's necessary that cycle times are bumped up a little bit, so minimum 64 milliseconds cycle time of I/O data, and then there are security parameters like the F factor on ProfiSafe that needs to be bumped up over 350 milliseconds maybe, and of course a certain percentage can use these settings and their wireless is very suitable, but for some it's not possible.
Right. For many applications it's perfectly okay with this example, yeah. One more thing that I'd like to discuss for AGVs is 5G, because everybody's talking about 5G these days, and 5G brings a lot of promise to AGVs. What are the demands that you see from the market there, Martin?
Yeah, exactly. So 5G is very promising regarding certain things like jitter, low jitter, and low latency and very high reliability. And this is where Wi-Fi today has maybe some shortcomings. What we see is now that the market is not ready, the broad market is not ready to adapt the technology, but HMS has made some very promising proof of concepts. We have an initiative called HMS Labs, where we already sell starter kits and we have some products that can be used in the industry. They are not certified worldwide and so on yet, but the proof of concepts are very promising, and we think that 5G is for sure going to be part of industry automation in the future, but the adaptation will take some years before we're there.
And perfect for AGVs.
Yes.
Okay. Thomas, Martin, thanks very much for being in HMS Tech Talks. If you want to know more about communication for automated guided vehicles, you can visit our website, hmsnetworks.com. Thanks very much for listening.